Okay, so what is soap? Soap are sodium or potassium salts of long chain carboxylic acid and have general formula this. But if we will go with a like very simple definition, so it's a long chain of carboxylic acid having cation of any metal like sodium or potassium like this. See, this is what? This is my R. What is R over here? R is long chain of carbon. And what is this? This is your cation, sodium, or we can also write potassium. And this is a structure of a carboxylic acid. So long chain of carboxylic acid, this is my carboxylic acid having a cation. This is my cation of any metal like sodium, or also we can write K over here for potassium. Okay, so this is the formula of soap. So here for R we can also write uh, like carbon. If we are writing carbon like carbon 15, so the hydrogen will be 31, and if we are writing carbon 17, so the hydrogen will be how much? 35. So what is soap, Rudra? Soap is a long chain of carboxylic acid. This is my carboxylic acid having a cation of metals like sodium or potassium. This is my sodium, or we can write potassium over here. And what is R? R is a long chain of carbon like C15. With C, obviously there will be hydrogen because it's what? Because it's a hydrocarbon compound. So carbon and hydrogen, and if we will take carbon 17, so we have to put hydrogen. How many hydrogen? 35 hydrogen. So this is the basic definition of salt, and this is your formula. Now this is also, this is your what? What is this, Roshni?
Ma'am, can you repeat your question?
What is this? C17H35, C15H31. This is R, na?
Yeah, this is R, and the other one is the cation of
Carboxylic
sodium.
acid.
Yeah.
Huh.
Yeah.
Carboxylic acid, and these two are cation. So this is my salt one. Let's say this is my salt one, and let's say this is my salt two. Okay, so definition wise, formula wise, clear what is salt? Main definition is this: soaps are sodium or potassium salts of long chain carboxylic acid, and this is your general formula RCO minus Na plus. Okay, so now we will see this. What is detergent? So detergent always reacts with a hard water. And what is the formula? What is the definition first? It is usually ammonium or sulfate salt of long chain of carboxylic acid. So see here in the salt, sorry, in the soap. In the soap, there was your what like this, no? Hmm. RCOO minus Na plus. This was your R, carboxylic acid, and your cation. And here, this is your formula of detergent. Your R. What is SO3? SO3 is sulfate salt, and Na is your cation. ठीक है? Na or K we can write. See, here Na or K I am writing, but here I wrote this carboxylic acid C and then double bond O. But here what I have to write? Here I have to write sulfate salt, which is SO3. So this is the difference between the salt and detergent formula, general formula. So both, like bath, we bath from what? Soap, and we wash clothes from detergents. Yes, and the detergent can also react with hard water, but soap cannot react with hard water. And this is your general formula, and your this is the general formula of your soap. And this is the main point that like manufacture. Just a minute. So manufacture, how soap got manufactured. So soaps are made from animal fats and vegetable oils by heating it with sodium hydroxide. So this whole process is known as saponification. Okay, so what is the chemical equation of this? Fats plus oil ester. It will react with your sodium hydroxide. Alkali sodium hydroxide means alkali is water soluble and sodium hydroxide is base. So that's why I wrote over here base water soluble. And with the help of heat, it will give you salt, sodium salt of fatty acid plus your glycerol alcohol. Okay, so this is how your soaps got manufactured, from your animal fats and by your vegetable oil. So this is the chemical equation. And here, if I'm writing like this, see, we all know that, For just a minute. Yes, what is sodium hydroxide? Sodium hydroxide is Na plus, NaOH. So Na plus and OH minus. And here for fat, oil, and ester. These are the three. First is your fat, oil, and ester. So your fat formula CH2O, and this is your R. Here also your R, and here also your R. So if this will react, this is your triester. Okay, these three are your ester, means like there are three now, so triester. It will react with your sodium hydroxide and it will form this. This is your soap, this COONA, and like this. This is your glycerol. CH2OH, CHOH, CH2OH. Now we will see that how this thing is forming. Yeah, so here CH2, see, here is your CH2O. This is your yeah, like this na OCO. So here how will I write OCO? This is your O and this is your CO. Okay. We will write in the formula of salt, and this is your R, this is your carboxylic acid, and this is your CH2. For this we will write like this, for this we will write like this. And now next what we have to do, we have to combine these all three with NaOH. Okay. So when we will combine this with NaOH, then what will happen? This is your Na plus and OH minus. So OH minus, see now what we are doing from this arrow thing, this is your arrow. So what we are doing, let me change the color. Bond will break positive and here what will happen, your bond will break. This is your bond, this is your bond, this is your bond. So what will happen, your bond will break, and what will come in the O, your minus sign will come, and in your carbon your plus sign will come. O minus, C plus, and C plus. Now what will happen? This is your NaOH, sodium hydroxide. So your Na, which is your plus, will combine with your O minus. Okay, and your OH, which is minus, it will combine with your C, which is having plus charge. Here also same thing will happen. This is O minus. So what will combine here? What will combine? Tell me what will combine.
CH2 will combine with OH and the carboxylic acid chain will combine with sodium.
Okay, yes. So here we are combining like this, and then what we will get at last. First let me write the first step. So here what we are getting, CH2OH. So here also we will get CH2 and your OH. The next step we will get CH and OH, and in the third step we will get CH2OH again. So here see CH2OH, CHOH, and CH2OH, and plus 3 D's. So how these we will get? Plus 3, this we will get for sure. Your C17H35. And here what is left? Your C is left, O is left, O and Na. Correct? So how we will write? We will write like this. COON. Like so. From these we are getting this. When we will heat your fats, oil, ester. These are what? These are my fats, or we can say oil or ester, tri-ester. These are combining with your sodium hydroxide, which is NaOH, and forming what? Forming your salt and this glycerol alcohol. This is your this alcohol, and this is your soap. Soap formula is this only. Here is the general formula of soap is this R COO minus Na plus, and here also we are getting like this only. This is your R, this is your COO, your Na, and this 3Y because of this 3NaOH. Okay, now you got it. The manufacturing part of soap, that how soaps got manufactured. See, this is also manufacture of soaps and detergents. Soaps are sodium potassium salt of long chain which have a general formula. This is the general formula. Soap we can also write like this. We can also write like this. Like with the C, obviously there will be H because it's a hydrocarbon. And what is a detergent? Which is usually ammonia and sulfate salt. So manufacturing is like this: fat plus oil plus alkali, which is your what base. So sodium hydroxide, if it will give heat, then it will become salt and your alcohol. Okay, so this part is done, alcohol thing. These done, or any doubt in the soaps, detergent, and in the manufacturing part? Done or doubt? Please tell me fast.
No doubt, ma'am.
Okay, next is your this the structure of your soap molecule. But first we will discuss this. So what is this zigzag thing? This is my zigzag thing, no? So this is what? Any idea what is this? This one, this zigzag one. What is this? This is your C17H35. It means this is your R, right? These are your carbons. And here, what is this? This is your O minus. And what is this? This is your this same Na plus. Okay, so here when we will combine soap with water, your sodium will detach and oxygen will be there. Means oxygen remains and sodium will be go here and there. So this is your long hydrocarbon. Why hydrocarbon? Because it's a mixture of your carbon plus hydrogen, which is known as your R, which is like C17H35 or anything if we say. Okay, next, see, this is like this structure only, na? This is your R, this is your R, this is your COO, means carboxylic acid, means O minus, this is your O minus, and this is your Na plus, this is your Na plus. Now here, if you will see, this is your long hydrocarbon chain, and what is this? This is your short ionic part, which is water soluble. This is your water soluble part, okay? And next, the left part is what? Now we will see. See, this is exact the same R thing, and here your O minus thing is left. Why? Because Na is detached, so Na is here and there, and O left with us means oxygen. So this is your oxygen minus. Oxygen is having minus charge. It means it is what? It is your polar end. है ना? What is polar end in chemistry? It is something like plus charge or minus charge in the chain. ठीक है? So what is your polar? Polar means plus, and oxygen is having minus charge. So it is like a polar end. And here in this end is non-polar. And why? Because this is not having any kind of charge. This is what? This is your hydrogen plus carbon. Hydrogen carbon, like if I'm writing, let's say C2H. Let me write first. This is what? This is your C2H. How many H? 1, 2, 3, 4, 5, 6. C2H6. So this is what? This is your, there's no charge. C is not having plus charge, H is not having plus or any minus charge. So this is your no non-polar end, and this is your what? This is your alkane. Why alkane? Because it's not having any double bond or triple bond, not alkane, not alkyne. And alkane have always a non-polar compound. What is alkane? Alkane is having a non-polar property, but your alkene and alkyne will have some kind of a polarity. Polarity means your plus charge or your minus charge. Okay, so here it is your no charge because hydrocarbons are always together. Where like with the carbon there's always hydrogen. Here with the carbon there's always hydrogen. So if with the carbon there's hydrogen, then it's a non-polar end. And here in this side, anyway, your this sodium is not with us, so that's why we are only writing oxygen minus, which is having a minus charge, which is your polar end. So this is your alkane, which is having non-polar, and these two will have some kind of a polarity. Now the main point is, see, if for water, if I'm writing, so you tell me water is like polar or non-polar? Water is having which property? Polarity or non-polarity property? Past. Rudra? Okay, for Safia it's non-polar. Okay, non-polar. Rudra, for you it's polar or non-polar? Come on, fast. Okay, for you, Roshni?
Mom, it's polar.
It's polar. Okay. And Rudra?
Is it polar?
Safia, what is H2? Like what is water? Water is HOH, which is having, and from here your bond will break. So it will be H plus and O minus. So this is a polar compound now. Polar is what? It's having a it's having a plus charge or your minus charge. So polar is having both the charges plus and minus. So it's polar compound. If in hydrocarbons you don't have any charge over here, that's why we are writing non-polar end. But here your oxygen is having any kind of charge, means polar compound. If no charge, then it's non-polar compound. So here what will happen? See, hydrocarbon stick means non-polar will stick non-polar, and polar will stick only the polar. Like polar property will only stick with the polar property, and non-polar property will only stick with the non-polar property. So hydrocarbon will stick what? Hydrocarbon means your H and your C will stick your oil, means it will stick with your oil, dirt, your fat, which is present in your dress or which is present in your body. Okay. Oil which is present in your dress and dirt which all are present in our body. So the hydrocarbon will stick to these, and this is called as water repelling, which is known as hydrophobic. Okay, this is known as your water repelling, means hydrophobic. Now, here in the polar, what will happen? The water attractive, polar will attract polar, so it's a water attractive. So it's what? Hydrophilic, and there will be the what is hydrophilic? Means attraction of water. And what is hydrophobic? You must have heard that hydrophobia word. So what is hydrophobia? Any idea what is hydrophobia?
It's like
Roshni,
fear
what?
of water.
So fear of water. So this is same like this. For non-polar, this is a fear of water, but for polar, it's a attraction with water. Okay, towards water. So remember, polar end is your hydrophilic, and non-polar end is your hydrophilic. So first, let me go with the definition part. Where is it? Yeah. Here, a soap molecule is made up of two parts, a long hydrocarbon part and a short hydrocarbon part, like this. This is the group of salt. So, soap. The long hydrocarbon chain, this is my long hydrocarbon chain, which is hydrophobic. है ना? We studied just now that this part is your hydrophobic. This is your long hydrocarbon chain, which is your hydrophobic. Okay. This part is your hydrophobic and therefore insoluble in water. This is not soluble in water. ठीक है? This is insoluble in water, but soluble in soil. This is insoluble in water, but it is soluble in soil. And what about the ionic portion? This is your ionic portion of soap molecule is hydrophilic, which is soluble in water and insoluble in soil. So these part, your zigzag part is hydrophobic. Zigzag means hydrophobia, and this circle part which is having a ionic portion, that's your hydrophilic towards the water, which attracts the towards the water, but which is insoluble in water. Now what is this cleansing action of soap? So soap molecules have different properties at their two ends. This end, the zig two ends like this, these are the ends. These ends are what? Your hydrophilic or hydrophobic, Roshni? And what about this end? This end is hydrophilic or phobic?
And that's hydrophilic.
These are hydrophobic na. See, these are non-polarant. Non-polarants are hydrophobic. Here also, here just now I told you that long hydrocarbon chain are always hydrophobic, and the ionic part is hydrophilic. Ionic, philic, long hydrocarbon means phobic. Okay, so these are what your hydrocarbon means hydrophobic. HP I'm writing, and this is your hydrophilic, so philic I'm writing. Okay, so these are the two ends of your soap. Soap is having two ends, hydrophobic and hydrophilic. So its one end is hydrophilic, which is soluble in water. This part is a hydrophilic, which is soluble in water, and this is a hydrophobic, which is soluble in fats, and this part is not soluble in water. Am I correct or wrong? Yes, Rudra, Sophia, this part is correct or not? This part is correct or not? Okay. Hydrophilic, soluble in water. Phobic means soluble in fats. Why? Because hydrophilic is insoluble in water but soluble in fats. So at the surface of water, your phobic end, or we can say this, the tail part of your soap will be insoluble in water, and the soap will align and the soap will align along the surface of water with the ionic end, है ना, in the hydrocarbon, which is your tail. So this is here, these are what? These are your tail, and these are your front part, means this minus minus part, and these are your hydrocarbon. So here inside water, these molecules show a unique orientation that keeps the hydrocarbon portion out of the water. This is keeping what? Your hydrocarbon portion out of the water, and this is done by the cluster of molecules in which these tails are in the interior of the cluster. Okay, let's show you this. This. So what is this? This is your in the center. This is your oil, or you can say dirt. Okay. And this is what? This is your the negative means the oxygen negative part, all the ionic parts, and these are your tail parts. So oil droplets, or we can say oil and dirt, And in the water, this is the water attracting part. Means these are what? These are your water attracting part. And these tail are not your water attracting part. Why tail is not my attracting part, Roshni? Why tail is not a water attracting part? Tell Safia why tail is not a water attracting part. Please unmute yourself and then tell. What you wrote, it is non-polar, and after that, it is non-polar and water is polar. Yes, we can also say it like that, that your hydrocarbon thing is a non-polar, but your water, correct. Water is your non-polar. Sorry, water is your polar, है ना? Water is your polar, and your ionic part is also polar. That's why polar will attract with polar. Here, your all these are ionic parts which are attracting with your water. Why? Because these two are polar and polar. And here I wrote na ki polar will attract polar and non-polar will attract non-polar. And here these are your tails, and these are non-polar. And this is what? Dirt or oil, and these are also non-polar. So that's why this is attracting this. See here, where I wrote, hydrocarbons stick to your oil and dirt, which is present in your dress or body. So these are what? These are your attracting part. And here in your water, your ionic part of the soap will attract, and what will not attract? Like your the tail part. है ना? Why? Because tail is your hydrophobic and your ionic is hydrophilic, and ionic is also your non sorry polar, and water is also polar. Water is how come polar? Because it's HOH. So here if your bond will break, so it will be H plus and O minus. So that's why these two will attract each other. This concept you got, Rudra and Roshni, that why these two are attracting each other and why not the tail part. Rudra, Ro-
Ma'am.
you got this part na ki
Yes, ma'am.
why water and ionic part is attracting each other and why not tail part is attracting with water. Okay, Roshni,
Yes,
why? Acha, now you tell me that
because
water is polar or non-polar,
water is polar.
and your the zigzag part, hydrocarbons, that was polar or non-polar? This
Ma'am, which
part, this one,
that one is non-polar and water is polar.
and this is your philic or phobic,
That is hydrophobic.
and this one philic.
Hydro.
Oh, good. So now, so here is your hydrophilic part, and this is your hydrophobic part, and this is your dirt. See, this is your dirt, and which will combine with dirt? Your hydrophobic part or philic part, Roshni? With dirt, what will combine? Philic or phobic? Fast. With dirt, philic will combine or phobic will combine? Tell now. Yes, very good, Safia. Phobic will combine. Here is your phobic part. Your phobic part is combining with your dirt or with your grease. This, like this, phobic. And what is this? This is your philic part, है ना? This is your water. This is your philic. Philic. Yes. So now your dirt is combined with your phobic part, and now philic will wash like water. Your philic is what? Philic is your water. Now water will wash out your all the dirt. So this concept you got, I guess. Now next is detergents. First, let me read this. To wash away the loosened dust particle, the form of missiles from the surface of cloth, it is either scrubbed mechanically or beaten or in the washing machine. Soap is able to clean since the oil dirt is being collected in the center. This is your center, which is the dirt and oil thing parts collected. Missile stay as collides in the solution and does not come together to precipitate due to ion and repulsion. The dirt, what is the note over here? That soap solution appears cloudy. Cloudy means that foam thing, because the ion aggregate to form spherical cluster, which form missiles that are large enough to scatter light. So here it's not only one missiles like this structure, there are lots of, like this, lots of. So this is your grease, who will combine with grease? Your phobic, and water will clean out your dirt and or anything. So your phobic part is your non-polar, philic part is your polar, and that's why philic part will combine with water. Why? Because water is your polar, and polar will combine with each other. And here is your detergent. Detergent we have already discussed that this is your detergent. Detergent. Detergent is usually ammonia or sulfate, like this. This is your sulfate. We can also write sodium, or we can write your potassium, like here I wrote. Okay, so done. Soaps and detergent. Here are the some points that what? First, we will see this. What is esterification? So when ethanol, this is your ethanoic acid, reacts with acetic acid. Okay, when ethanol, yeah, means or alcohol reacts with your acetic acid, a carboxylic acid, in the presence of acid as a catalyst. This is your acid which is present as a catalyst. Then what will form? A fruity a fruity sweet smelling liquid which is called ester. This is formed when your ethanol reacts with your acetic acid in the presence of your acid as a catalyst. Your ester will form ethanol. Okay, so what is esterification? Rudra, what is esterification? Safia, what is Roshni? What is esterification? What will combine with what? Ethanol will combine with your acetic acid. Acetic acid, yeah, and with the acid as a catalyst, so it will form your ester. Ester. Okay, with acetic acid, it will form ester. So this is your esterification. Now here reaction of carbonates and hydrogen carbonates. In the reaction of this acetic acid with carbonates or hydrogen carbonate, what is forming? Your carbon dioxide gas is formed, and this is an example of your acid base reaction. Okay, in the reaction of your acetic salt and your hydrogen carbonates, your carbon dioxide gas is formed. Now, what is the use of the acetic acid? It is used for making vinegar, used for the preservative in pickles. We use this acetic acid. It is used for the synthesis of other compounds like esters. And what is acidity? What is acidity? Acetic acid will combine with your sodium metal. It will form sodium acetate, and your hydrogen gas will evolves. So this is the chemical equation of your acidity. Weak acidity of acetic as compared to your HCl is because of your low ionization. Okay. So this is your acidity. Reaction of base means acetic acid will combine with base means sodium hydroxide. So it will form sodium acetate and your water. And what is the physical property? What is ethanoic acid? Ethanoic acid is also known as acetic acid. The formula of ethanoic acid is this. What is the physical melting point is this. During winter, you have to go through all these. These are only chemical equations, so you have to remember all these chemical equations. So during winters, it often freezes in cold climates and form ice like the flakes, like this acetic acid. And it is a weaker acid than HCl, but stronger than alcohol. So please go through these some important notes. This one, and this one you have to go through. Okay. So here, what is the use of ethanol? Ethanol is used in your alcoholic drinks. Your ethanol is used. It is used for medicines like the tincture of your iodine, cough syrups, and some other tonics. Your ethanol is used, and alcohol is used in your petrol since it is a cleaner fuel and rise only to this carbon dioxide and water when we'll burn it in a sufficient amount of air. And this is your chemical property reaction of sodium. Sodium is reacting with ethanol, forming sodium ethoxide, and hydrogen gas evolves. Dehydration, sodium reacts with H2SO4. Removal of water molecules from a compound is known as dehydration. What is dehydration? Removal of a water, like our body also feels sometimes dehydrate. Why? Because from the body, your water level decreases. So that's actually a dehydration. Removal of water molecules from a compound, or we can say, like, as per our body, removal of water from the body is known as the dehydration. Then what we need to do? We need to like drink more water. है ना? So here ethanol with hot concentrated acid, if it will get heated, then what we will get? Ethene and water. So the above reaction, this acts as your dehydrating agent. What? This will act as your dehydrating agent. So now your chapter is done. Each and every topic is also done. Any doubt anywhere? Rudra, Roshni, Safia, from starting covalent bond. These are your dot structures. You know. Next was what? Properties of covalent bond. The difference between the ionic and the covalent compounds. Here you, is your allotropes, diamond, graphite. Next was your versatile nature, catenation, tetravalency. This was your hydrocarbon. What is hydrocarbon? Alkenes, alkynes. These were the formation. These were also the formation. Next was your cyclic compounds. These are important. You have to remember homologous series, nomenclature, all the IUPAC name, in, ein, in, this substituents. Safia, you you clear now about this topic substituents, Safia, or any doubt?
Yes, ma'am.
Substituents done? Okay. Okay, so tell me the name of this. This one. Do everybody and tell me the name of this. Faster. Roshni, what is the name of this chain?
Just a minute.
Huh.
Ma'am,
Hmm.
it's 3,4 dimethyl nonane.
Nonane? It's seven. Only seven carbon is here now. So for seven, what we write?
It's heptane.
It's heptane. Okay. And Rudra means 3,4 dimethyl heptane. Yes. 3,4 dimethyl heptane. Safia, it's seven carbon over here. You no need to add these two carbons. These are the substituents. See, these are your substituents, na? CH3 methyl. So no need to count this. Only we have to, the first step was we have to find the longest chain. So this is your longest chain. Second step, we have to start numbering. From that side, ki your substituent will get closer. So here, if I'm start numbering, your 3 and 4 is the smallest. So 3, 4 di, why? Because there's two substituents, CH3 for methyl and 7 for carbon. Safia, you are not getting this part? It should
Yes,
be
ma'am.
7.
I got it.
It should be 7. No need to count the substituents. We will never count. Only we will count the longest chain. Okay, tell me this one fast. First, Safia will tell, then after that, Roshni and
Is it bromopropene?
Bromo.
Uh,
You have to write the number also.
uh,
Don't
it'll
forget to write number.
it'll be 1 bromopropene.
3 bromopropene. This is more, we will give more priority to the in and ein bond na, than your substituent. Here I wrote na. So from here we will start numbering 1, 2, and 3. So it will be 3 bromopropene. Okay.
Yes, ma'am.
Hmm. Please remember this. There are some points, substituents, your nomenclature, and this priority thing, that's double bond is more prioritized, this double and triple than your substituent. And here also one more point that your functional group is more prioritized than your double and triple, and then after that your substituent will come. So remember this also, functional group. Okay? Okay, so tell me about this one. Last question. It's already 5:43. Safia, OH, if you want, OH is your OL. Okay? Now tell me. OH is your OL.
Ma'am, it's propan to all.
Propane to all. Propane to all, but we have to remove E. Okay? Propane to all. Okay, very good.
Ma'am,
And hmm,
the teacher in my school, she said that we can also write it as 2 propanol.
yeah, we can write to propanol. And last, this one. No, not this one. Okay. Acha, okay, this one. Last question. Safia, please try this one. Safia, anybody, Roshni, propane to own. Yes. Yeah, very good. Means now you got the concept. It's already 5:45. Your chapter is done. And on Monday, I will take test. Okay, on Monday there will be test. On Monday, the date is 21st of November. Okay, then thank you. Bye bye.